Okay, great. So I'm going to start my lecture for today. So we are continuing our lecture, which we have completed uh, last lecture on topic 1 until 4. So today I'm going to start with topic 5, which in this lecture is stated PM05. So in our previous chapters, we have talked about how the world perform project management and how does it different from the regular process and the project. And then we also talk about the manager, the functions of the manager, and the organization structure, and also developing the team in the project, who's involved, what are their tasks. And then we have also mentioned about planning the project based on the activities, which is called WBS, or work breakdown structures. And we have also talked about the budgeting of the project, okay, cost estimation, and how are we going to allocate resources, and a little bit on FMEA, on the basic risk analysis. So basically, we call it project management triangle. The main thing is especially on the scope of the project, right? And then it will also involve cost, as well as the duration or the time to implement the project. So these all three items will affect the quality of the project implementation. So this is called it project management triangle, where it has three item to be looked at. So the scope has been discussed in chapter 1, 2, and 3, or topic 1, 2, and 3. And then on last talk or last lecture, we have talked about the cost. Okay, and now for this chapter, we will talk about the time. How can we manage the implementation of project in terms of times or the duration? So of course, when we talk about project management, the scheduling is becoming very important, and it requires us to follow some carefully steps or flow in order for the schedule to take shape. And then to do so, uh, the project planning or the project scheduling is very important, and it relates to the scheduling process, which has been defined by the project management book of knowledge, which is the Society of Project Management Career. So I give you example. When we give you an assignment, so it is very important for you to break up the task or the activities of the assignment given. Here I give you example to identify the topic. All right. So identify the research topic, and then writing the first draft of paper, and then do the editing, and then do some modification, rewrite, and then prepare a presentation, to prepare the presentation slides. And then next will be completing the draft or the final draft. And then you will make sure before the presentation can be done. So you need to complete the presentation. And at the end of the semesters, you will hand in the paper or the report, and also present the topic in the class. or in the lecture session. So these are an example of a project which is given as a type of assignment that you have to break it up into few individual activities. Therefore, a list or a table actually couldn't help much on the implementation of the project, or couldn't help much on the control or how we going to make sure the implementation of the project can be run smoothly. So it is very important, rather than just listing the activities such a way like this or in a table. So it is very important to draw the project as a mean of a diagram. We call it a network diagram. So basically a network diagram, which is a schematic display of the project's sequential activities and the logical relationship between them, because some of the activities are related to each others. All right. So these are all the activities. Some are quite related to each other, and some need to be completed before the next activity can be started. So that's very important to make sure that not the activities not written in the list or table manner, but it is very good to transfer the list of activities into a network diagram. So this is example of a sequential logic of the activities that's been shown, has been given earlier. So we put it into A to H steps. Okay, list number one, it's called A, identify topic, and then research, paper draft, and so on. This is all a sequential flow of the project implementation. So it's one single row. This is example of how uh, the list or activities in the project are drawn in the network diagram. But there are a better alternative rather than the sequential network diagram. And this is called it non-serial sequential logic. All right. So rather than just a very one singular or one path, such as this one, all right, project can also be identified or drawn in terms of network diagram, such as non-serial sequential logic. Right. So there are sequential activities from A to C. However, there are activities which is non-sequential or in parallel with each other, which are D, F, and also E, G. But then after tasks or activities F and G are completed, then the project can continue with activity H to finish the project. So H relies on the combination of activity F and also G. So this is another alternative ways to describe the project activities in terms of network diagram. So the importance of network diagram is that it shows clearly the interdependence of all tasks and also work within the project implementation. Because a network is better illustrates its interrelationship among activities and also project personnel, and it facilitates communication flow as well. And a network diagram actually helps with master scheduling of organizational resources, because it shows times as well as various personnel must be fully committed to project activities. A network diagram also able to identify the critical activities. Critical mean that what are the main activities need to be completed. Of course, all activities are important, but by having this network diagram, you can identify which are the critical activities, and this can distinguish or differentiate them with the less critical activities. So, of course, there are many activities for the project implementation. When we draw the activities in terms of network diagram, we are able to identify which part or which activities are the most critical. And network diagram also help us in determine when you can expect the projects to be completed. Right? In the network diagram, we will stated the days or the time. Usually, each activities will take, and at the end, when the project can be completed. So we have discussed on in previous chapter, which is chapter 3 or topic 3, on work breakdown structure, which help us for monitoring and controlling project activities. All right, but in project management, there are two primary methods. In this case, PERT and CPM. So these types of network diagram will help managers to plan and also to timing the project involvement involving sequential activities. So PERT and CPM charts actually identify the time required or the day required to complete activities in the project and the order of the steps of each of the activities. Historically, PERT uh, defined as Program Evaluation and Review Technique. This is the full name of PERT, which is created or invented by United States Navy by Alan Hamilton, which is the American management consulting firm, and also Lockheed Aircraft Aerospace Company. So PERT, usually they estimate the probabilistic of the activities as well as the activity duration. Another method, which is called critical path method, which will be used mainly in our subject, which is being created by DuPont the Moss Incorporation as a company. So this critical path method estimate activities duration as well as included both time and cost estimate, which allows time and also cost trade-off to be used. So I will show you the PERT diagram as well, but at the end of the explanation of CPM network diagram. So this is example of PERT and CPM. So usually we have a start, and then we have this one, the duration of the project, and then at the arrow we have the activity A, which takes 25 days to complete. And here in this arrow, we stated activity B, which have a duration of 15 days, and so on. So all the project diagram should have start and also on the end to indicate complete project implementation. So usually it will be colored in such a way to explain the critical, at least to differentiate the critical path activities. So in this case, the red colored circle and arrow is the critical path. Later on, we'll be explain to you what is critical path, right? So this is very important to identify, which is colored differently, or can be black or whatever, but it must be shown clearly and the critical path and also the normal path. So PERT and CPM networks, actually both methods they employ networks to schedule and display task sequences. And both methods identify a critical path or sequence of tasks that could not be delayed. So when we talk about critical path, that means that path, the activity along that path cannot be delayed. It must be completed as stipulated in the project planning. Right? If any of the activities delay in that critical path, the project definitely will be delayed. So both methods identify activities with slack. Sometimes they call slack, sometimes they call it float. That could be somewhat delayed without extending the time required to complete the project. Some activities can be delayed. For example, it takes 5 days. Some activity it takes 5 days to complete, right? But by having this network diagram, so we will be able to know whether that particular project can be delayed for how many days. All right. So basically, when we talk about the critical path, that means all the activities along the critical path cannot be delayed. All right. Later on, I think when I show you the example, you should be able to understand. While PERT and CPM use slightly different ways of drawing the network of activities, and so anything one could do with PERT, one could also do with CPM, and also vice versa. It's quite similar. It's only that the way the network diagram are drawn and the way they are put all the information is a bit different, slightly different. So these are some of the PERT or CPM jargon in the network diagram. So we have item called activity. So actually these are the tasks or set of tasks, right? And also it will use resources or the time to indicate how many people will be used or how many days or how many hours the task need to be completed. And also we have the event. This will state the resulting from the completion of one or more activities and is consume no resources or time. So the predecessor activities must also be completed. We also have milestone. So milestone actually the event that's marked significant progress. Right? What are the significant progress that you can identify? For example, in building a house, so setting up, clearing the foundation of the house is completed, can be marked as the milestone or the significant progress. That means foundation has been completed. So that's the milestone, one of the milestone for developing a house. And then of course it is a network, so it is based on the nodes and also the arcs, which is used to illustrate technological or relationships between each task. And of course, you should have again start and finish on the right and start on the left. And arcs are always tipped with an arrowhead to show the direction of the precedence activities. And then you have path, which is the series of connected activities between the two events. So we have critical path and also we have critical time. So as I mentioned earlier, critical path is the set of activities on the path that if delayed, will delay the completion of the project. So this helps us in managing the project well and also help us in predicting the project completion well in advance. And then of course the critical path will determine what are the critical time, which is the time required to complete all activities on the through the critical path. So here example of a serial activities. which shows the flow from one to the next in sequence. So we have activity A. After activity A, then you will have activity B, and so on. So it is very important to note that the predecessor is an activity whose start or finish control the start or finish of another activity. Predecessor means, for example, the predecessor for B is A. Before B can be completed, A need to be completed first. Before B can be started, A should be completed first. And a successor is an activity whose start or finish is controlled by the start or finish of another activity before it. So B, the successor for B is C in this case, right? So B need to be completed before the C activity can be started. So these are also the link which also can be considered as the parallel or concurrent. So when the nature of the work allows for more than one activity which is not related, so you can implement it separately or in parallel. So these activities are actually called concurrent or parallel project path. All right. So because E does not depending on activity D, that means E can also run by itself only after C activities has been completed, right? So it's quite independent. It's not related. G, E, and G does not relate to activity of D and also F. But H requires the completion of activity F and also G before H can be started and complete the project, the activities, I mean. So we have the terms called merge and burst activities. So merge activities or merge, I mean, you have multiple activities and then will be merged together before activity D can be started. Burst, that means the activity A need to be completed before another 3 activities which rely on activity A to be started or to be completed. So this is an example of a network diagram of a complete activity network. So you have, unfortunately, there's no start. It should be a start and also finish at the end. So start with A and then completed A. There are 2 activity, B and C. And then once C completed, then D can be started only if B is also completed. Once completed, D completed, activity D is completed. F can be started once it's completed, right? H can be started only if E and C or and G are completed together, right? So there are burst and also merge, merge and also burst activities. Right, so far any question? Okay, great, no question. So two types of network diagram, AOA network, or we call it activity on arrow, which usually associated with per network diagram. And the other one is AON network, which is called activity on network. All right. So AON network will show each task as a node and linking the node with arrow that show their technological relationship. And is often associated with the CPM. So CPM will be used throughout the chapter. So once you graduated, if you involved in project management, then they might use either one, AOA network or AON network. Okay. So AOA versus AON has been described in the following diagram. Right. So we have BDC, BDC, and so on. Right. but activities of AOA is on the arrow. For AON, the activities are on the node. So this is node. So this is arrow. That's why they call it activity on arrow, activity on node, because the activity are described on the arrow. So this is an example which I will show you. We have a task which is described by A, B, C, D, E, and so on. And then usually we will inform you, or we will state the predecessor, or what are the process comes before it, before the activities in the next column. Usually this will be given, or usually you will determine in your project planning what activities should comes in sequence. So you will see that A and B without predecessor, that means A and B stand alone. It can just be started anytime without any dependent on any other activities. C will be completed once A is completed, right? B will be completed. D will be started only when B is completed. But you will see here there are two activities need to be completed before F can be completed. So this is usually how activities are shown or prescribed in a network diagram. So we start with stage 1. So as mentioned, you need to have a start node here, start. So A is by its own. So A will start, and B will start without any predecessor. That means it start directly at the beginning. All right. Because task A and task B have no predecessor, so they follow the start node. So then we connect them to the starting node, and then we indicate this is activity A, this is activity B. Okay, and we will go on where you can see that C, depending on activity A, so we draw node A, node C, all right, with arrow coming from activity A. Okay, and then when you talk about activity D and E, so this activity D and E comes from one's activity B, similar activities, which is B, completed, which has its predecessor. So D and E has a similar predecessor. So the way to draw it, you need to draw the node D and E beside B, and then draw the arrow from B to D and also B to E. So they have a common predecessor for D and also E. Then the network is easily completed, where task F has both E and D as predecessor, while G follows E. Sorry, F, C, and D, and G follows E. So because they are normal tasks, we can tie all loose end to a node label finish. Right? Because E and F is at the end of the project or the activity, so we can consider this both will finish the project. Okay, so this is how a completed sample of activities on node network drawn using a very simple by looking at the table, the task and also the predecessor. So I also will show you how AOA network is drawn in this case. Again, the AOA mean activity on arrow. So rather than you draw the activities in a node, so you need to state the activities on the arrow, but you have to put the sequence number such as 1, 2, and so on. So A considered 1, so you draw 1, but the activities is written on the arrow. Similarly with B, right? It's flow or activity that have no precursor, in this case A and B, and the completion of the activity result in event, right? Call it event, which is nodes often drawn as a circle, number 1 and number 2. And so on. If we go, we start with C, which has predecessor of A, all right, and we put the numbers 3. And then for D, we have sequence number 4, and we have activity D. And then for E, which has predecessor from B, which is B here, and then we indicate this is sequence number 5, and so on until we able to complete the AOA network. Okay, so again, activities on arrow, that means activities are written on the arrow, all right, but it also the note in this case indicate the sequence number 1, 2, 3, 4, and so on. So this is example of AOA network. They also have, we call it, some dummy tasks. For example, in this case, we can handle F in simple to equivalent way by connecting the nodes following C and D in figure 5, right, with an arrow drawn with a dash line. We can also have dummy task. Okay, to indicate with the arrow. This is called dummy activities. Dummy activities. This is not, sometimes you can just add one more activities to show that is something used in situation where two activities have the same starting and finishing nodes, where a single activity connect two or node. Okay, but of course activity D, in this case dummy task, does not take any time or duration to be completed. So again, I would like to say out that we will use AON network throughout this course, right? Because they are used, basically they are used most of the popular project management, especially software. And also the important advantage of AON notation is that the network are easy to draw, right? AOA network, particularly when they have more than 15 or 20 activities, are quite difficult to draw by hand, of course. And with modern software, for example, the Libre project or Project Libre or Microsoft project, this is of course not a serious problem because it is based on software. It's easily to generate. But usually in this software, they will generate AOA network. Sorry, AON. AON. Because by default, it's like that. So we have here exercise on finding, once we drawn the critical path, once we drawn the network diagram, so it's very important to find the critical path. What was the critical path and critical time? Do you remember? You have slide with you, right? Anybody? What's the critical path? Everybody's sleeping, huh? You know, sometimes it's boring to have this online lecture when there's no feedback at all. Okay, anybody? Before I continue? Okay, no response, very quiet. Okay, never mind. So this is example where it is given the activity A to J and the predecessor of all activities are given. And this time we'll give you the duration, the duration day for each of the activities. This means A will take 5 days to be done. B will take 4 days and so on. Okay. So the question is draw A or N with label of activity and duration as like this. A5. A5 we put this activity and duration like A5. So in this case, we'll have given there are 3 stages to draw this network diagram. Okay, so stage 1 of a sample network is like this. So again, we start and then we draw A5, A which has 5 days of duration, and it has no predecessor, so it's started directly from the start. And then we have C, which relate to activity A. All right. All right. Thank you, Al Kuwaili. Yeah, longer sequence to achieve project. Yeah. Okay. So C, it has predecessor from A, right? So C should started only when A completed. Similarly for D and also E, it has the same predecessor. So A to C, A to D, and A to E. And the duration each is 3, 4, and also 6. All right. So if you follow the same method, so you will end up a complete network diagram like this. Okay. Easy, right? Yeah, should be easy. Only if you try to do it later on. Right. Avoid having several of the avoid having several of the arrows crossing on. So we don't want to have arrow like this. Yeah. So try to avoid crossing arrows through the node. Okay. So in this case, that is why it is very important to measure. For example, F should be below here, not F up here, because if activity F is here, then you have to cross the link or the arc through some of the nodes. So the network is kind of very difficult, not neatly presented. Okay. So from here, once you have this network diagram, all right, completed. So there will be a question, right? So how long will the project take? There are many, right? There are ways the project takes. You can take this path A, D, G, F, and then it can also A, E, H, J, and then A, C, F, I, and then B, F, I, and finish. So how many? How many paths? 1, 2, 3, 4. So there are 4 paths before the project can be completed. So the question is, how long will the project take? And then which activity shouldn't have any delay? So we want to see whether C activity can be delayed. For example, we want to delay for 1 day or 2 days. Is this possible for activity C, or is it H can be delayed? All right. So we want to know that. And then if it's allowed, what is the maximum duration that any activity can be postponed without affecting the project timeline? So we also want to know if can be delayed, if the activities, not the project, I'm talking about the activities, okay? If any of the activities can be delayed, and then for how long? What's the delay limits? All right. So the delay usually we call it float or slack for the activities. All right. In order to find the critical path and also the critical time, so here are the terms that we usually use, that we will use actually, the ES, EF, LS, and also LF, right? So usually node will be displayed as such a way. So we have ES on the top left, and then we have EF on the top right nodes, and we have top left, we have LS, and we have top bottom right, we have LF. So ES mean earliest start time. That means when is the earliest time it can start, right? And EF is earliest finish time. So when we have the earliest start time, of course the activity has its own duration. So this is the earliest finish. So you start early, you finish early. And LS is the latest start. That means what are the latest time this activity can be started. So with that, with adding to activity duration, we'll have the latest finish time. So that's why we call it ES, EF, LS, and also LF to determine when is the earliest and when is the latest time this activity can be started. So in order to finding the critical path, we have two methods. The first one using forward pass calculation or FPC, and then we have to do BPC, backward pass calculation. So basically, okay, Eman, you can read this one. It's good to. All right. Now we start with forward pass calculation. So we have activity A, which have 5 days of duration. So because it started from start, and then so at the earliest it can start is of course 0 lah, because it start at the beginning, right? So ES is 0 and EF is ES plus the duration. So ES 0 plus the duration 5. So that's why this box will become 0 and also 5. So when we talk about forward pass calculation, we're talking about filling the top ES and also EF for the activity. For activity B, we know the ES is 0. So EF is 0 plus 4, so it's 4. So that's why ES is 0 and EF is 4. So we'll get something like this. All right, for them. And then we will have for D, E, and F. So we have determined these two parts, right? So we focusing on this part. So for D, E, and F, we know that the earliest finish, right, and latest finish is the same. So we just put it as a successor cannot be started until all predecessors are completed. So because 5 days is required, right? So we this activity D, E, and F can only be started on the day 5. So ES for C, D, and E is 5. Right? So ES for D and E will follow this from the earlier finish for activity A. So it's 5. And the EF is just addition of the duration of the task. 5 plus 4 is 9. 5, 6, 11, 5, 3, 8. And then we will have FPC or the merge activities. We continue with activity F and also B. So this is a bit tricky. A successor cannot be started until all predecessors are completed. So for activity F, right, because activity F, they have two predecessors. Right, activity F here, it has two predecessors, C and also B. Okay, so if we look at the earlier start of activity B is 0, which is derived earlier. and earlier finish of activity B is 4. But activity C has early start day 5 and earliest finish is 8. So in order, so which one to be choose here for F? So F will be chosen based on the maximum early finish from the predecessor. So because this activity completed is 4, EF is 4, CEF is 8. So the F activity F will start 8. That's why I say a successor cannot be started until all predecessors are completed. Although activity B can be completed after the fourth day, but C need to be completed on the 8th day. Therefore, F can only be started if all the predecessor activities are completed. All right. So that's why you need to choose the longest one between these two predecessors. So ES for F now is 8. And EF for F is 8 plus 4 is 12. Then we have finished forward pass calculation, such as drawn in this drawing. Okay, so far, any question that you confused? Okay, start from 0, 0. Yeah. Mubarak, the question?
Excuse me, doctor. For
Yeah.
the duration is always fixed on all for the all letters.
Okay, the activities, The activities here. You mean this one?
Yes.
Yeah. This diagram is based on the activity that we have designed earlier. That means when you want to do project planning, you should have such this one. For example, A5, this will be given actually. Or you should determine what are the content of this. Okay, so this will be given. So based on this table, then you should be able to draw the network diagram. Without it, you cannot. Right? Is it clear, Mubarak?
Yes, doctor. Thank you.
Okay. Okay, so next one will be the back propagation calculation. Okay, so this one I reserve for next week. All right. I hope you can try to understand this. Next week I will continue this, and then try to complete this chapter 5 next week. Okay, it's a bit tricky, but I'm sure you are able to understand it. Okay. Question. Okay. I think this class only. Okay, ready. All right. Our next week meeting, I will continue on to complete the network diagram calculation. We have to determine the critical path and also critical time as well as float and the slack. Okay. So with that, thank you very much. So don't log out. I will pass to you the the QR the QR code for today's lecture. Okay. Can you see the QR code or can you scan it? Okay, great. All right. So with that, thank you very much. Hope to see you next week to continue and complete this chapter 5. Thank you. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to all.
Thank you, Dr.
You're welcome.